Hello everyone. Today we will submit a Q-Chem job to HPC, which is now Discovery at USC. So first of all, we need to log into our HPC system. For that, on macOS system, we will use Terminal. Currently, Windows also supports SSH, so you can use just command prompt for that. In Terminal, in order to access your HPC account, you need to use SSH commands and then type the address of the server you are trying to reach. So in this case, it is SSH space your username and then discovery.usc.edu. You will hit enter, and first of all, computer will ask whether you want to trust the server. We obviously want to say yes. Then you need to type in your password. And it will ask for dual authentication. Okay, so we are logged in now, and you can see that we are in new Discovery system, which is called CARC of USC. And you see that my prompt also changed, so it is now, initially it was my computer, and now it is Eremin at Discovery 2. So in order to see what your account can provide in terms of the computational time you have, you can type command my account and hit enter. It will give you all accounts you have access to. So in our case, this one is for Chem 545 class, one account for molecular dynamics simulations, and one account for my personal project. You also can see what computational time you have per each account. So this time will provide you the number of hours per CPU you do have. And also it will address all the time that you already spent on each account in calculations. If you want to see how much disk space you do have, the command is my quota. So in this case, you can see how much disk space you have per each directory you have access to. So your home directory, which is your primary directory where you will be logged in after you use the SSH command, and now it has 100 gigabytes limit, so you basically can do a lot of operations there. All users have access to two types of Scratch directories, Scratch and Scratch2. The main difference between home and Scratch directories, home directory is backed up frequently. Both Scratch directories are not backed up at all. And also you should have access to project directories if such project was assigned to a project directory. And these directories are also backed up and have very big limit of 5 terabytes. In order to see what nodes are available for computation, you can type command sinfo2. Sinfo command by itself will provide you only type of nodes and how many of them are available currently, but sinfo2 command also provides number of cores and amount of memory for each compute node. So HPC has big compute nodes such as EPIC nodes with up to 32 cores, and relatively smaller compute nodes with 8 CPUs with all of them are with 2 sockets. So basically you have twice threads per CPU per nodes for each calculation. So next, let's see how we can transfer our data and actually run our calculation using HPC. To transfer data, the best way is to use the SFTP clients. In this particular case, I prefer to use CyberDuck. You can use FileZilla or any other you are familiar with. In order to access your account folders and transfer data there, the best way is to use the HPC transfer to node, which is created specifically for data transfer. So I already have this connection established. So let's just see how it is set up. So basically, what you have, you just can specify your name. You need to give the address, and address should be HPC transfer to. It is not Discovery, because Discovery itself can also give you access, but in this particular case, you need to transfer data efficiently rather than using time of the nodes, which is supposed to be just for connection. You have to provide your username, and you need to type in your password. Also, you can specify and go directly to a certain location where you want to access. Because initially, if you use HPC transfer login type, you will go directly to the root directory of HPC transfer 2, which is root directory of our HPC system. And we want to access exactly our particular folders. So in this case, it is home1 / your username. And you can see those paths in my quota command. So you can just copy paste those and use it. So if we access it, it will ask you for the password. And then you have to go through the dual authentication. As soon as you confirmed, you will go directly to the folder you are trying to access. And now you can just drag and drop folders. And I already have a folder for the Q-Chem test run. And we can just drag this folder to the home directory, to my home directory. Let's look what we do need in order to actually run the calculation. So today I would like to submit just a benzene molecule, a very small and simple molecule, just to see how it goes with the submission. So the primary difference in the input file, you have to specify the amount of memory you want to access, because the default with Q-Chem on HPC is just the minimal amounts. So in order to be able to run an actual calculation, you need to provide both total memory and static memory. So let's this time access for 32 gigabytes for total memory and 2 gigabytes for static memory. We will run the optimization procedure with PB0 method and df2 tzvp basis set. The main difference between running the Q-Chem simulation on your local machine or even submitting into Q-Chem server, you need to add a script file that will actually submit your calculation to the compute nodes. So for that, we are using qchem.run script. The extension doesn't matter much. It's just for you to specify that this is the actual run file. Let's look what is inside. Our HPC is running under the bash shell. So first of all, the first line of the script should be the specification of the shell we want to make this file executable. Then we need to specify our parameters. Our HPC is using Slurm for the queue, and in order to get into the queue and to ask for the compute node for our calculation, we need to specify several key parameters. So first of all, you can just give a name for your calculation. So you can just change this to anything you would like. You need to specify the partition. As you can see in our sinfo2 commands, we do have different partitions: epoch 64, main, and 1 week. So epoch 64 is specifically for those big nodes, main compute nodes, main partition for compute nodes for regular use, and 1 week partition for the calculations up to 1 week long. Then we need to ask for how many actual nodes we want to get access. For most simple calculations, you just need one node because we will mostly use the OpenMP parallelization. So we will ask just for one compute node. Now, HPC provides you an opportunity for node sharing. So if you are okay with that, you do not need the next line, which is as batch exclusive. However, if you want to access nearly all the memory of the compute nodes, or you do need nearly all the cores of your compute nodes, you do not want to share your node because in this particular case, your calculation might fail just because the memory will be taken by another calculation running on the same node. So in most cases, you want to keep the exclusive usage of current compute nodes. Next, we want to specify how many tasks we are running. So if you are running OpenMP parallelization for just one molecule at one node, the number of tasks will be the same, it will be just one. And you need to specify how many actual CPUs will be used for this particular task. You need to get the CPUs per task. And in this case, we will use 8 CPUs. So basically, we want to access just 8 CPUs on one particular node. And each of these features, as you can see, they are starting with sbatch. So sbatch is the keyword pounds sbatch. That pound sbatch is a keyword to ask the Slurm to look for certain features you are asking. So basically, the number of compute nodes per user is limited, and however, the number of CPUs is actually limited as well. So you either can get several nodes with a lot of cores, or you can just take many nodes with with a lower amount of nodes, or with a lower amount of cores. So basically, you are limited overall, I think, 100 CPUs per task overall for all current, or 200 CPUs per task for all current simulations. Next, we need to access the memory. So in this case, I'm typing 32 gigs. This is exactly for the amount of memory I'm asking in my input file. This is a lot of memory, but we will use it just to see how it works with Slurm submission. If you will type 0 instead of the 32 GB, the keyword mem equals 0 will not ask for 0 memory. It will actually ask for all memory available at the particular compute node you are trying to reach. So you can either use the memory limits specified in the sinfo2 commands, or if you are sure you are just accessing one particular compute node, you can type 0 and it will get you access to all memory available. However, in this particular case, you will have to keep an eye and be sure that the amount of memory you ask in your input file matches the amount of memory available per compute node. Next, you need to ask for amount of time you want to access this compute node. We will ask for only 30 minutes. However, the maximum time available at HPC at USC is 48 hours. So you have up to 2 days available compute time. You also can have an option and ask the server, the Discovery server, to send you notifications via email on the state of your computation you submitted. So you need to use the mail keywords and type your email address, your USC email. And the next line, mail type equals all, will give us an opportunity to get all notifications. So when your calculation is submitted, when it is finished, and also in the times when, for example, your calculation has failed, which is very unlikely, but it's better to have that information as well. The last line is the account type. So if you do have your personal accounts and some other accounts, you do not want to spend time for calculation, taking it for certain projects from different account which this calculation does not belong to. So for Chem 545 class, we do have the Krylov _ 547 accounts, and you need to specify that in order to submit a calculation using the using time available for that particular one. All accounts are provided in your My Accounts information, and you also can see what is your default account. So in my case, default account is Eremin _ 338. And if I want to submit the calculation either using Krylov or Malguin accounts, I need to specify this particular one, or otherwise all my calculations will be run using the Eremin _ 338 one. So this part is the part how you can access and ask for computational time, and then in the script you need to specify what particularly you want to do using this compute node. So we need to ask and open the Q-Chem software. In order to do that, we will first ask to purge all the models, and Discovery now uses the model system. So each software is basically a model which you can load, and some models are loaded as default, but in order to not overcomplicate your computational system, you do not want to have software which is not required for this particular task. So we will purge all models which were preloaded when we just accessed the compute node. Q-Chem is compiled using the GCC compiler. So first model that you have to load prior loading Q-Chem is actually the GCC. So we will model loads GCC /8.3.0. And after that, we can load the Q-Chem itself. So the command is the same, model load, and then we need to specify the Q-Chem, which is in this case Q-Chem -openmp /5.3. So in order to see which models are available in the command line when you are logged in, you can type commands model avail, hit enter, and it will give you all models currently available. The D in brackets will provide you information which version is the default, and we can see that we do have two Q-Chem versions. One is MPI parallelization and one is OpenMP. So depending on what calculation you want to run, you can load one or another. The method is exactly the same. Next, we need to specify our QC Scratch directory, which will be used for temporary Scratch files for the calculation. For this, we use the command export / and QC Scratch equals, and then you need to provide the path to the directory where Scratch files will be stored. According to USC Discovery HPC team, Scratch2 is the fastest directory currently available, and since in most cases Scratch files are not necessary, so and we do not store them, it is okay that we will keep them on the file in the directory which is not backed up. However, if you are interested in them, you can save them and transfer to your home directory, and then they will be safe. So I created the directory in Scratch2 Eremin, and I called it Scratch, and I just specified it as a Q-Chem. In order to access my Scratch directory in the CyberDeck, we can go up to the root, access Scratch2. It will take a little bit of time to list all the directories because there are many of them for all the users. We will then just type access my directory, and you can see that this is my Scratch directory, and this is the directory for the Scratch files. And this particular path, Scratch2, your username, Scratch, Q-Chem, is the path for the QC Scratch variable of the Q-Chem environment. Next, we have the variable for a number of actual threads for OpenMP parallelization. So it's OpenMP number of threads, and this value should be the same as the number of CPUs per task you asked. In order to do so, Slurm has already several preset environmental variables, and in order to keep it consistent and not mistake in this, we will use one of those preset environmental variables, which is slurm underscore CPUs underscore per underscore task. And it will keep it match with CPUs per task number. Otherwise, you can just type it manually. So in this particular case, we can type just 8, and that will work as well. However, I prefer to keep it as a variable. In order to run calculations, Slurm knows where our directory from which we submitted a file for the calculation was stored. So we need to go to that particular directory and to store all the output files and everything in that one. So for that, we need cd, which is a command to go to another directory. And then again, we're using the Slurm variable, which stands for the directory from where we submitted our file. Host name will just keep you up to date and will print out the name of the compute node you accessed for the calculation in the Slurm output file. And the last line is just exactly the Q-Chem command for the calculation itself. So it is Q-Chem /-nt, which stands for number of threads. In our case, it is 8. And then we type in the name of the input file, which will be fenlh.inp space and fenlh.oot, which will be our output file. So this file, this Q-Chem run file, the Slurm job script, is required on our HPC in order to run the Q-Chem calculation. So let's go to our home directory. And as you can see, we will just drag this folder and it will appear in our system. In order to see your files on the in order to see what files you have access to, you can type command ls, and it will give you all the files stored in the current directory you are logged into. By default, you are logging into your home1, your username directory. By default, you are logging into home1, your username directory, and you can see all the files exactly the same as in the home directory in our CyberDeck. In order to go to the particular directory where you have your files, you need to type command cd, the same as we had in our job script. So we type cd and then q/chem, hit enter. So we now are in the Q-Chem directory. In order to check whether you are in the directory you are interested in, you can type command pwd, which will print the path you are in. If you hit enter, you can see that we are in home1, your username, Q-Chem. So this is exactly where we want to be. We type ls, and we can see the files, the input, the Q-Chem input file and Q-Chem run slurm job script file. So in order to submit an actual task, we need to type command sbatch space and the name of the job slurm job script and press enter. So you now can see that we have submitted batch job, and you can see the number of this job file. In order to see your queue, you can type command sq space -u space your username, and we can see this is our job we just submitted. It has its number, the partition that we used, the name we specified, your username, the time, it is 0 because it's not running currently, and number of nodes we asked for. Also, it will give you the reason at the node list where it stands, so it's looking for resources. So we can type sinfo2 again to see whether we do have any idle nodes. And unfortunately, there are none in the main partition right now, even though we asked for very small amount of time, but we have to wait until the calculation is actually done. So we here do see that there are several idle nodes for the epic nodes. So let's cancel this job and try to submit to see how it actually goes. So if you by accident want to actually cancel your job, you do need to type command scancel and space and type the number of the job you just submitted. And if we type the Q command, so we do see now that the job is no longer there. Also, since we canceled the job, as you can see, I already received an email specifying that the job I just canceled was actually canceled. So let's change the partition to epic 64. Calculation will be very fast, so it's not gonna spend any time, but we will be able to see how the system goes. So we will delete the former file and just transfer our new, let's just double check. Yes, it is correct. So we're still in the same directory, nothing changed. So we can check, we can type ls and we still see the Q-Chem and input file. So let's try to do that again. Qchem.run. Okay. So you can see that actually it's been just a few minutes, but already there were 60 jobs submitted within the same time. Let's see what is with the queue. And we can already see that our calculation is actually running. So let's type ls once again, and you can see that our calculation is indeed running. So we have the input file for the certain job. If you have multiple jobs, we already have our output file created and acquiring, and we have the Slurm output file, which will specify all the details about the calculation. Also, if we update our CyberDuck, we will see that all files are there. So actually, it looks like the calculation already ended. Yes, indeed. And this is the third email saying that the calculation is actually complete. So we will open our folder with the initial files, and let's transfer both all output files here. So Slurm output is just the outputs for the job. So basically the command line web browse file. So this is, we asked for the host name. So this is exactly the host name we asked to print into. And then we have the Q-Chem command line outputs. So you can see all the commands. And this is our output file. So you can either open it as usual with your IQmol interface, and we do see all the geometry steps. So we're just 3 steps there. And at the end of our Q-Chem output file, we can see, thank you very much for using Q-Chem, have a nice day. So thank you, Q-Chem, for providing this calculation. And this is how you submit your Q-Chem job to Discovery HPC at USC. Thank you.